Hello everybody. So here is a problem that I've taken right off our My Math Lab assignment that I really think that we should do. I'll have to warn you before I get started. It's a fairly involved problem, but I think if you listen to what I have to say here, then you'll be able to solve this problem or a similar problem all by yourself. So here goes. We're talking about dealing a 13 card hand from a deck of 52 cards. And when we say that we're going to get 13 cards from a deck of 52, we just mean the standard deck of playing cards, which you see right here. We've got clubs, diamonds, hearts, spades. Those are the suits. Each one goes ace, 2, 3 through 10, then jack, queen, king. And so you can see it all laid out right here. That's what we're talking about. All right. Now, I want to know what the odds are that if I have a random 13 card hand, like, so you take the deck of cards, get 13, so it's all shuffled, get 13 cards out, and that's random, just they're dealt, it's like nobody knows what they're going to be. What are the odds that that hand of 13 cards contains at least 3 kings? Okay, all right, so here goes. First, I want to start with, what do we need to ultimately know to solve this one? It says, what's the probability that a random 13 card hand has at least 3 kings? Okay. So the way that I would ultimately figure that out is I would take how many 13 card hands have 3 or 4 kings. I have to count that total number up, and that's going to be a huge number. Okay. And divide that by how many 13 card hands there are altogether. Okay. So why do I say I need to know how many 13 card hands have 3 or 4 kings? Well, the wording of the question was to find the odds that a random hand has at least 3 kings. What's at least 3 kings mean? It means 3 or 4. So, okay, I'd have to count up how many 13 card hands have 3 kings and how many have 4 kings. Add those together, divide it by how many hands there are all together. All right. Okay, so this is what I'm after right here, and I'll have to figure this out in parts. All right, so I'm going to divide this into several parts so that we can focus on each part and make sure that we get it before we go on to the next part. Okay, so how about we do this? See this bottom number? How many 13 card hands are there in total? So the way that I would figure that out is I would use the combination 52 choose 13, which all this does is tell me how many ways there are to choose 13 cards from 52. That's what that does. And you'll find that this is a function in your calculator. All right. So I have a simple calculator right here. And in one of the menus, I have combinations. Okay. All right. So you'll have to learn how to use your calculator. If you can't figure something out on your calculator, then you can ask me about it, and between the two of us, we'll figure out where it is. Okay. So that's that bottom number. It tells me how many 13 card hands there are taken from a deck of 52. Now, I use combinations here. Now, hold on a second. So far in our class, we've learned about permutations and combinations, 2 different things. I'm using combinations here because the order that the cards are doesn't matter. If you play cards, the order that they're dealt to you or the order that you arrange them as you hold them makes no difference. Okay? So for combinations, we're counting things up where the order doesn't matter. Okay? In permutations, the order does matter. All right? So like in a phone number, all the digits, the order those digits are makes all the difference. Okay, but that's not the kind of thing we're dealing with. In a hand of cards, the order doesn't matter. We're using combinations. All right, so that number right there is how many total 13 card hands there are if you take them from a deck of 52 cards. Okay, so we got that bottom number. Let's move to the top number. Okay, so I need to figure out how many 13 card hands have 3 or 4 kings. Let's do that one at a time. Let me count up how many have 3 kings and then how many have 4 kings. Okay, so the way that we do that is a little bit intricate, but let me explain. And like I said, I think if you hear me out here, then you can solve this kind of problem or a similar problem on your own. So if I'm going to make a 13 card hand that has 3 kings in it, then I would have to choose 3 of the 4 kings available. That's what this part is. Choose 3 of the 4 available kings in the deck. Remember, the deck has 4 kings. Okay? All right. And then I would have to choose the remaining 10 cards from the 48 non-king cards. So see how this is 48 choose 10? I've already chosen 3 kings. How many cards are in the hand? 13. So that means there's 10 left. And what are you choosing the 10 left from? Well, if I'm going to have 3 kings, then there are 3 kings, and then there are 10 kings that are 10 cards that aren't kings. Okay? So from those remaining 10, I have to choose from the 48 non-king cards. So I'm getting that this way. In the deck, there are 52 cards. 4 of them are kings and 48 are not. Okay? So there you go. There you go. So choose 3 out of the 4 kings available. Then choose 10 other cards from the 48 non-king cards available. Multiply those together. That's how many hands have 3 kings exactly. That's a big number. Okay, we're going to get big numbers here. These combination and card dealing problems and lottery problems and so on can have just colossal numbers. All right. Now the reason why I multiply these together is by the multiplication rule, because I'm doing this and then I'm doing that. And when we do things in sequence that way, we multiply the possibilities. All right. Okay. So that's how many have 3 kings. What else did I need? I need to know how many 13 cards hands have 3 kings or 4 kings. Okay. All right. So how many have 4 kings? Now I can put this together in a similar way. If I'm going to put together a 13 card hand with 4 kings in it, then I have to choose 4 kings from the 4 that are available. And then I have to choose 9 other cards from the 48 non-king cards available. What's 9 and 4? Oh, well, that's 13. That makes 13 cards. Okay. So these are done in sequence. I'm doing this and then I'm doing that. I multiply those possibilities and I get that colossal number. It's a big number. Okay. All right. Now I think I have it. I think I have everything I need. I can count up how many hands have 3 kings and 4 kings and add them together. That's how many have 3 or 4. Or that's how many have at least 3. And I can divide that by what I already found to be how many 13 card hands there are in total. So here's what that's going to look like. Okay. I got this number and that number. Add them together for the total possibilities. Divide by this. Now these I've just copied down from over here, but I wanted to put it all together. Okay. Calculate them individually if you want to. Add them together. Divide. And you'll get 0.0438, which means that in a bridge hand, I don't know how to play bridge. It's a card game, but there are 13 card hands. The odds of getting one that has at least 3 kings is about 4%. That's what that number is, about 4% chance, a little more than 4%. But the decimal is what we have right there, rounded to 4 decimal places. Okay. So that's how it works out with this one. It's a little intricate. It's a little bit involved. But like I said, consider the breakdown. I've tried to divide it into distinct steps. I try to be real neat with my labeling so that you can follow how we count everything and put it together. And ultimately, like I said, I hope that means that you can solve this kind of problem on your own.